Life had a golden age, and we almost missed it. The Permian period, 252 million years ago, was not a primitive world struggling to exist. It was a masterpiece. The most complex, layered, thriving biosphere this planet had ever produced. Trilobites had been patrolling the seafloor for 270 million years. Brachiopods carpeted the ocean floor so densely their fossils still form entire rock layers today. Crinoids, sea lilies, swayed in underwater forests so vast they had their own weather. Above the water, gorgonopsids stalked the land, saber-toothed, warm-blooded, the size of a hippo, the lions of a world that had not yet invented mammals. Life had survived 4 extinction events before this. It had earned its confidence. But confidence is a trap. Beneath the surface of what is now Siberia, something had been building for millions of years. A pressure, a heat, a slow geological fury coiling in the dark. And 252 million years ago, it woke up. It was not an asteroid. There was no single moment of impact, no flash of light, no sudden silence. It was worse than that. It was patient. The Siberian traps, not one volcano, not a chain of volcanoes, but an eruption zone the size of Western Europe, began to bleed. For 2 million years they bled. The lava flows that remain today still cover 7 million square kilometers. The total eruption produced enough basalt to bury the entire surface of Earth under 30 meters of rock. But lava was not the weapon. Beneath Siberia, the magma was pushing upward through something far more dangerous than rock. It was pushing through ancient evaporate deposits, buried mountains of sulfate and salt, and through hundreds of meters of limestone. Every cubic kilometer of magma that passed through those deposits didn't just produce lava. It produced carbon dioxide, sulfur dioxide, chlorine gas, pumped directly into the atmosphere, continuously. For 2 million years, the sky was being poisoned from the inside. And everything living beneath it was about to discover what that meant. The warmth came first. It always does. Carbon dioxide blanketed the atmosphere and the planet's temperature climbed 8 to 10 degrees Celsius. To a geologist, this is almost instantaneous. To every living thing on Earth, it was a sentence. The Glossopteris forests, seed fern jungles that blanketed the southern continents, ancient and stable, the forests that would one day become the coal seams we burn today, died. The root systems failed. The soil bled into the rivers. The land animals that had built their lives in those forests watched the ground they stood on dissolve beneath them. Then the acid arrived. Sulfur dioxide reacts with atmospheric water. It becomes sulfuric acid, the same concentrated acid that turns the clouds of Venus into a death trap. It fell as rain across every continent on Earth. It stripped nutrients from the soil. It killed what forests remained. It turned rivers and lakes into slow poison. But the land was not where most life lived. The land was just the opening act. The real murder was happening in the ocean. The ocean did not die all at once. It died in stages, each one quieter than the last. First, the acidification. Carbon dioxide dissolving into seawater forms carbonic acid. The ocean's pH began to drop. Shell-forming creatures, brachiopods, trilobites, the reef-building corals, found the very chemistry of the water working against them. Their shells thinned, softened, dissolved. Species that had existed for hundreds of millions of years discovered that the ocean they were built for no longer existed. Then the warmth reached the deep water. Warm water holds less oxygen. The great thermohaline circulation, the planet's circulatory system, the deep-sea currents that carry oxygen from the surface to the seafloor and nutrients back up and began to slow, then stopped. The deep oceans suffocated. Oxygen levels in the bottom waters dropped towards zero. The seafloor died. The decomposition of billions of tons of dead organic material consumed what oxygen remained. The dead zone deepened, spread outward, rose toward the surface. And a dead zone is never truly empty. Something else always moves in. In oxygen-dead water, the sulfur bacteria rule. On the modern Earth, they are kept small, marginal, confined to isolated corners, the deep Black Sea, certain swamps, seafloor pockets, wherever oxygen-breathing competitors cannot reach them. They are survivors of a more ancient world, waiting. In the Permian Ocean, the waiting ended. As anoxia spread across the global seafloor, the sulfur bacteria found themselves in an environment built for them. An entire ocean without competitors, without limits. They bloomed, they consumed, they spread. Across the floor of every ocean on Earth, simultaneously they took over. And they exhaled. Their metabolic waste is hydrogen sulfide, the gas of rotten eggs, stale death. In small quantities, merely toxic. In the quantities now rising from the floor of a global ocean, it became something else entirely. It attacked the ozone layer. It dissolved the shield between the surface and the ultraviolet radiation of space, and it rose into the air. Scientists have found the evidence locked in Permian-Triassic boundary rocks, fossil spores with ultraviolet damage written into their genetic structure 252 million years later. The chemistry of what happened is still there, still readable. If you were standing on the Permian coastline at the peak of this event, you would smell it before you understood it. The wind off the water would carry something wrong, a sulfurous edge, a chemical signal older than thought. Your eyes would begin to water. Your throat would close. You would have minutes, perhaps less. The ocean had become a weapon. The sky had become its ammunition. 96% of all marine species, gone. 70% of all land vertebrates, gone. And then the number that should stop you cold. 33% of all insect species, insects that had survived every extinction for 400 million years. Insects that would survive the asteroid that killed the dinosaurs. The Great Dying is the only event in the history of life on Earth that broke them. The trilobites, which had walked the seafloor since before complex land life existed, a lineage 270 million years old, did not survive. They had outlasted everything. The Great Dying was the thing that finally found them. The reef systems collapsed and did not recover for 10 million years. The ocean did not return to full biodiversity for 30 million years. Modern humans have existed for 300,000 years. We have been here for 1% of the time it took the ocean to recover. After the extinction, geologists find a layer they call the coal gap. Coal forms from the accumulated debris of forests. For 10 million years after the Great Dying, there is no coal anywhere on Earth because there were no forests dense enough to make it. What filled the silence was fungus. The Permian-Triassic boundary layer, examined on 6 continents, is rich with fungal spores, because fungi consume the dead. And for a geological moment, the world was almost entirely dead, but something lived, in the deepest burrows, in the highest ground away from the poisoned coastlines, small, unremarkable, warm-blooded. The cynodonts, mammal-like synapsids the size of rats, not predators, not dominant. The kind of animal that survives a catastrophe not by being the strongest, but by being small enough to hide and adaptable enough to eat almost anything. They survived. And from them came the mammals. From the mammals came every warm-blooded lineage that would ever live on this planet. The whales, the elephants, the bats, the primates. Us. If the sulfur bacteria had bloomed a little faster, if the eruptions had lasted a little longer, if the burrows had been a little shallower. There is no us, not a different version of us, not an alternative path, no version of this story in which something called a human exists at all. The Great Dying cleared the board. The world that emerged from it, the Triassic, was empty in a way the Permian never was. Every dominance hierarchy, every established lineage, every ecological niche that the Permian had built over hundreds of millions of years, gone. And into that emptiness evolved something new. The archosaurs, the ancestors of the crocodiles, the ancestors of the birds, the ancestors of the dinosaurs. The Great Dying is the reason the age of dinosaurs happened. You cannot have the age of dinosaurs without first destroying everything that came before it. Extinction is not the end of the story. It is the condition for the next one. 252 million years ago, this planet came as close to biologically dead as it has ever been. The ocean suffocated. The sky turned to poison. The land fell silent for millions of years. And then, slowly, stubbornly, impossibly, life came back. Not the same life. Something new. Something stranger. Something that eventually, after hundreds of millions of more years, would look up at the night sky and wonder what happened here. The universe does not care whether anything survives, but life, it turns out, did not get the message.